Greetings, seekers of the unknown. Today, we're touching upon a subject that sits right on the edge of science and pure madness. For the majority of us, the answer is death. Non-existence. That final moment when the lights go out and you simply cease to be. We've been conditioned to view this as a biological certainty. But what if I told you that modern theoretical physics has provided us with a loophole? What if, from the perspective of quantum mechanics, you are mathematically incapable of dying? This isn't religion, and it's not mysticism. This is the concept of quantum immortality. Today, we're going to break down how the equations of Schrödinger and Everett strip death of its finality. We'll journey from terrifying thought experiments involving weapons to the very fabric of the multiverse. Get comfortable. In some parallel reality, you've probably already clicked away from this video, but here, in this specific branch of events, we're going to dig for the truth. To understand how immortality works, we first have to shatter our conventional understanding of reality. We are used to the classical physics of Isaac Newton: if I throw a ball, it follows a predictable path. But in the microworld, the world of elementary particles, everything functions differently. Here, superposition reigns supreme. A particle can exist in two states simultaneously. It is both a wave and a point. It is here and there. The famous double-slit experiment proved that as long as we aren't looking at a particle, it behaves like a ghost, smeared across space. However, the moment an observer steps in, the collapse of the wave function occurs. Reality picks a single path. But in 1957, a young and ambitious physicist named Hugh Everett asked a question that changed everything. What if the collapse doesn't exist? What if the universe doesn't pick one option, but instead, splits into two? This was the birth of the many worlds interpretation. Every time a quantum event occurs, and they happen trillions of times a second inside every one of your cells, the world splits. In one reality, you blinked; in another, you didn't. In one universe, the dinosaurs went extinct; in another, they still rule the planet. Now, let's move to the most chilling part of our story. In the 1980s, physicists Max Tegmark and Hans Moravec proposed a thought experiment to test Everett's theory in practice. It's called quantum suicide. Imagine a laboratory. Inside is a device, a quantum trigger connected to a gun. The trigger measures the spin of a particle. If the spin is up, you hear a dry click. If the spin is down, the gun fires. The probability is exactly 50/50ths. You pull the trigger. From the perspective of an outside observer, there is a 50% chance they will see you die. After several attempts, the mathematical probability of you surviving becomes nearly zero. To them, you are mortal. But what happens from your perspective? According to the theory, your consciousness can only exist in the branch of reality where you are alive. You cannot perceive your own non-existence. You pull the trigger, click. Again, click. 10 times, 100 times, 1,000 times in a row. Mathematically, this is impossible in a single universe, but in the multiverse, there is always a branch where the particle fell into the misfire position every single time. Your consciousness will filter into those worlds where you continue to exist. You will feel like the luckiest person in history, while in millions of other worlds, your friends are currently attending your funeral. Many ask, if the world splits every second, why don't I notice it? The answer lies in decoherence. Our bodies are too large and too hot to maintain quantum purity. We are constantly interacting with billions of atoms of air, light, and dust. This interaction entangles us with the environment. Imagine a tree. The trunk is your past. Every branch is a choice or a quantum event. Standing at the tip of one branch, you cannot see what is happening on the neighboring one. But both branches grow from the same root. To the universe, you are the entire tree. But to your consciousness, only the line you are currently traveling exists. At first glance, quantum immortality seems like a gift. Who wouldn't want to live forever? But let's consider the consequences. There is a very dark side to this coin. First, the aging problem. The theory says your consciousness will persist, but it doesn't promise you'll stay young. Imagine being 200 years old. Your body withers, your organs fail. But in the quantum world, there is always a tiny, nearly impossible chance that future medicine or a random mutation will allow you to live one more day. You could end up trapped in a frail body that cannot die because consciousness keeps choosing the living branch. Then there is total solitude. With every passing decade, you will transition into realities that become more and more improbable. All your loved ones will die in your branch of reality. Eventually, you might find yourself as the last human on Earth, or the only living being in a world that simply refuses to end for you. Finally, quantum injury. If you are in a terrible accident, quantum immortality ensures you survive, but it doesn't guarantee you emerge unscathed. You could exist in a state of a coma indefinitely, simply because that is the only path for your consciousness to continue. Of course, we can't prove this theory without risking our lives. But there are anecdotal phenomena that make one wonder. Take the Mandela effect. Millions of people remember Nelson Mandela dying in prison in the 80s, even though he became president. Skeptics call it memory bugs. Proponents of quantum worlds believe these are the echoes of our consciousness occasionally jumping between very similar branches of reality. Or look at the anthropic principle. Why is our universe so perfectly fine-tuned for life? The quantum immortality answer: there are an infinite number of dead universes, but we simply aren't in them. We are here only because this is the specific branch where the conditions for our emergence and survival aligned. If quantum immortality is real, the very definition of death changes completely. Death is something that happens to others. It is a tragedy for those left behind in the old branch. But for the one leaving, it is merely a transition to a different script. This forces us to rethink the value of life. If we are doomed to eternal existence, our task is to make that existence as high quality as possible. We are eternal wanderers in an ocean of probabilities. Every action you take, every thought you have, literally creates new worlds. This brings a colossal responsibility and, at the same time, a colossal freedom. You don't need to fear the end, because the end does not exist. There is only an infinite now. Friends, the topic of quantum immortality is a challenge to our common sense. Do you believe that we are merely mathematical functions that cannot be zeroed out? Or do you think this is just a beautiful mind game played by theoretical physicists? Let me know in the comments. If you were offered the chance to know for sure that you are immortal, at the cost of losing everyone in your current reality, would you accept that knowledge? Thank you for diving deep with me today. Hit that like button, subscribe to the channel. In this reality, we need to stick together. And remember, as long as you are observing this universe, it continues to exist specifically for you. See you in the next video, or the next life.